Hi there. As you can see, I'm going to tell you something about Rubocop. We will see what it takes in order to build a custom cop, and then we will piggyback on Rubocop in order to surface runtime information, template methods in a larger code base. But first of all, who in here is actually using Rubocop? Please raise your hands. Okay, that's almost everybody. Great. Keep your hands up if your Rubocop never fails you on CI. Any hands up? Okay, so we all go through the same experience, but anyway, failing on CI should be a thing of the past because Rubocop these days integrates nicely in your IDE and autocorrects most of the violations for you. But either way, whether you're fixing on a command line or in your IDE, it is a great tool to help us write better code, and it's also easily extensible for specific domains. So what does it actually do under the hood? That's rather small. For every file it's inspecting, Rubocop, it does three things. It does a lot of things, but mainly it's built an AST, which represents the structure of your code. Then it iterates each node in this AST and calls the configured cops. And finally, the cops themselves, they are responsible for adding offenses and doing the autocorrection. Now, this is way smaller than it should be. Shall I try to fix it, or? Okay. So we proceed. Assume we want to do something simple, like rewriting an inverted array empty statement to the roughly equivalent array any. How do we do that? We inherit from the cop base, and then we have three simple tasks. We define the message we want to show. We implement an onSend method, which receives the specific node from the AST, every node that is a method call, or that receives a method call. And finally, we use the def node matcher macro in order to define a new method called notEmptyCall, which will pass a specific node pattern to match the specific nodes that we are looking for. A working example looks something like this. OnSend is pretty simple. We simply check if this is a notEmptyCall node, and if so, we add the offense. The node matcher is slightly more complex, but it's better read from the inside out. So the three dots represent a wildcard. That's any expression receiving an empty call, and that is surrounded by the outer brackets, which invert that logic. And to get autocorrection is only a few steps away. We simply extend the autocorrector module, and then we capture the receiver of that empty call inside our node pattern using the dollar signs around three-dot wildcards. And then when adding the offense, we can use the block syntax in order to replace the entire node with the final source code we wanted to write. So that's a pretty simple example, and you probably expect something like this. When I write that in the editor, I get a little icon telling me that something is wrong. I can display the message that we defined, and on save, it actually auto corrects that code for me. But so implementing cop is simple, but we are not don't have to limit ourselves to the AST alone. In the next example, we want to surface template methods which the AST does know nothing about. So we have to get a bit more creative. We are choosing a two-step process. So in the first step, we are actually loading the application files and extracting the runtime information, which has all the method definitions available. And then in the second step, we use that information in a custom cop in an efficient way in order to highlight that information. So loading classes is pretty simple. We then partition our base and subclasses, collect the shared methods, and write that down in a simple YAML structure, which could look something like this. Here I've chosen a chess domain, so we got like a basic movement, castling movements, and en passant, and they do share some common methods. The relative, okay, and within the Rubocop itself, we first want to be efficient because we're reading external data and we want to do that only once. So we tell it, use it to use the same cop for multiple sources, and then we define two methods, which is on new investigation, which gets called for every new file it will be processing, and the onDef node, which is called for any method definition it encounters in the AST. And in the final example, we load all the external method definitions that we have generated beforehand. We extract the relative path of the processing file in our onNew investigation, and then we simply dig up the methods for that specific class. And in case the method name of the node that we are visiting is included in that list, we register an offense. And this could give you something like this. So we are able to highlight that this specific method is actually overwritten in various other classes in our Jest code base. Okay, so for more information, please check out the Rubocop documentation, which is excellent and goes into much more detail about what can be done. Okay, thank you.